Hi, welcome back to this video. In the previous videos, we learned how to read data in pandas and how to identify different kind of variables. In this video, we will move to the third step in data exploration, which is univariate analysis. Let's dive deeper and see the topics that we'll be covering in this video. First, we will understand what is univariate analysis in general. Then we'll see why do we need univariate analysis at all. And next, what do we look for in univariate analysis? And finally, we will have a look at how do we perform univariate analysis. Let's get started. So, what is univariate analysis? Univariate analysis is where we focus on single variable at a time, summarize it, and use this summary to understand the data better. Let me put it this way. In univariate analysis, we understand several aspects of data, like what is the type of available data? Does the distribution of data look correct? Are there any anomalies in the data, etc. So why do we need univariate analysis? Let us understand this with the help of an example. This is the box plot distribution of age of all the people on Titanic. So people who do not know what a box plot is, box plot looks something like this. Here we have the lower fence. This is called the upper fence. This represents the median. This is the first quartile. This is the third quartile. So anything above upper fence or below lower fence represents some sort of anomalies or outliers, which we'll see in the upcoming sections. So median represents the median value of the variable, and these represent, for example, here we have the 25% of the data. This is the next 25% of the data, this is the next 25% of the data, and this is the last 25% of the data. So in general, this box contains the middle 50% of the data, and the rest 50% is contained within these whiskers. These things are called the whiskers, this and this. So this is what a box plot is. So now that you know how to interpret a box plot, can you identify what is wrong with this distribution? Yes. See these 2 points in the red circle. These are way higher than the maximum value represented by the box plot. To be precise, these represent 400 and 450 values of age, which is quite impossible for humans to have. So, univariate analysis just helped us detect an anomaly in the data. Now that you know you can use a box plot for univariate analysis of the age variable, can you use this box plot for univariate analysis of the sex variable? No, because there are different methods of univariate analysis for different type of variables. We need different methods for continuous variables and categorical variables. We'll be discussing each of these categories separately. First of all, let's discuss about univariate analysis for continuous variables. So what do we look for while performing univariate analysis for continuous variables? While working with the continuous variable, we look at its central tendency and dispersion, such as mean, median, and standard deviation. Then we look at distribution of the variable to identify whether it is right skewed or left skewed. Univariate analysis also helps us in identifying missing values in a variable, along with detecting the presence of outliers. Now we'll see two methods of performing univariate analysis on continuous variable. First, the tabular method, and second, the graphical method. For example, tabular methods are best suited for analyzing mean, median, standard deviation, and missing value in a variable, whereas graphical methods are best suited for checking the distribution of variables and detecting outliers. Let's have a look at the tabular methods available in pandas for univariate analysis. The describe function applied on the Titanic pandas data frame returns all the required result in a tabular form for all the continuous variables. So this is one such output created by the describe function when applied on the Titanic dataset. The Titanic dataset has continuous features like passenger ID, survived, P-class, age, etc. And for each continuous variable, the describe function returned results like the count of the variable, mean of the variable, standard deviation, minimum value, 25th quartile, etc. So this was all about the tabular methods available in pandas for univariate analysis of continuous variable. Let's move to the graphical methods. In the graphical methods, we have histogram for checking the distribution of the variable. So right over here, I have a histogram of the distribution of age, where on the y-axis is the frequency and on the x-axis is the age. So we can see that there is a nice curve on the right of the histogram, whereas there is a peak on the left side. If you need to create a histogram in pandas, you can use the hist function provided by the pandas data frame. Next is the box plot distribution, which we studied a bit earlier. Box plot is generally used to detect outliers. So for example, here we can see that there are some outliers. This is again a distribution of the age, where on the y-axis we have the age, and these lines represent the minimum, 25th, median, 75th, and the maximum value of the age without the outliers. So in order to plot a box plot, we can use the box plot function provided by the pandas data frame. Let's see all the topics that we have covered up till now. We studied what is univariate analysis, why do we need univariate analysis, and what to look for while performing univariate analysis of continuous variable. Next, we studied how we can perform univariate analysis of continuous variable. Thank you.